Hi, I'm Jeff Bertoft, and welcome back to the Windows 8.1 Developer Geek Edition. So in this section, we're going to be talking about HTML5 apps, and today with me, I have here David Kachu. David, would you like to introduce yourself?
Hello, everyone. Thank you for inviting me. Yes, I'm David. I'm from France, as you may notice from my accent. I'm a program manager on everything that is related to HTML5 on the same team as you. And my specialty, we can say, is around 3D and WebGL. That's why I'm here today.
Right. So we're going to be looking at some really exciting technologies today, and one of them is WebGL. That's why we have David here. And he is French, so at any point I may have to translate what he's saying from the French English to the normal English, but we'll make it through, and we're glad to have you here. Thanks for coming, David. All right, well, let's get started. So whenever we talk about HTML5 and JavaScript, we always start with the web. So the web is a viable platform. It's the first platform that we think of when we talk about HTML5 and JavaScript. That's where the Windows users spend a lot of their time in the web browser, looking at web apps, looking at web pages. And in Windows 8.1, we've introduced IE 11. So we have a new browser with new features, new technologies that it supports in the HTML5 space, and new tools for the developers as well. So we're going to start by walking through that. So the web platform. Starting off, the web is an integral part of Windows. So when we think about the integration points between the operating system and the web, Windows 8.1 adds even more of those with the ability to do live tiles, which we'll talk about in a minute. But we've introduced a lot of new features into IE 11 with Windows 8.1. And standards is one of those areas that we continue to develop. We want to adopt more web standards. We want to make it easier for developers to write not only for Windows, but to write one web app that works across all platforms. And so as new standards are created, we work to adopt those.
Yep.
And Microsoft ourselves have also submitted some of the great features that we introduced in IE 10 as web standards to the W3C so that other browsers can support them as well. One of the other great features about working with Windows and web apps on Windows is that we have IE 11 across all the platforms. So it's not only on Windows, it's on Windows RT, it's on Windows Phone. We have Internet Explorer running on Xbox as well. So when you write for a web app for Windows, that same great experience works across all of those devices. So what's new in the web platform? We're going to be talking a lot about WebGL today, but there's a lot of new enhancements that come at the same time. Encrypted media extension, which allows you to use media that you want to have encrypted, like we'll do an example with Netflix in a Netflix video, right in the browser without needing any plugins. High DPI support. Pointer events, we actually are using unprefixed version of pointer events for IE 11. So if for those of you who aren't familiar with that, pointers is a new W3C specification that allows you to write for a pointer for a single type of input, and then have it work across all the different input devices. So whether that be touch, pen, or a mouse as well. And David, you know a little bit about pointer events. You have a framework that you wrote. Is that right?
Exactly, because this time Microsoft submitted a W3C proposition, and it works well on IE 10 with a prefix version, and as you said, with a non-prefix version on IE 11. And I wrote a small framework called NGS, ngs.codeplex.com, where you can find this polyfill, which allow you to use the unprefixed version of the specification and make it work on Chrome, on Firefox, and on Opera. On this kind of browser, we just gather every kind of input and generate a new pointer events model. So you can just write once and it works everywhere.
And that's really important at this point because when we write for Windows, we've been using pointer events since IE 10.
Exactly.
It was introduced in Internet Explorer 10. But other browsers are just now seeing it come through their pipeline. So as a web developer, we always like to write our code once and have it run everywhere.
Exactly.
So you can use pointer events with a polyfill like CanJS and have that same code run natively in Internet Explorer and then utilize the polyfill.
Because
in the
if we
platforms.
detect the presence of native implementation, obviously the polyfill will do nothing and just shut off.
Right. So additionally, in IE 11, we see a lot of new layout refinements. So we have an updated version of Grid, CSS grids, and we have our Flexbox implementation upgraded as well to meet the changes in the standard. So those give you a lot of control over the layout of your screen. One of the advantages to using HTML, in my opinion, is the ability to pair it with CSS.
Exactly.
CSS gives you ultimate control over the way that you want to lay out your screens. We're going to talk a few minutes about some of the different apps that we use here at Microsoft and that we write in HTML. And one of the drivers for that is the fact that we do have that low-level control over layout with CSS that is more difficult in other languages.
Exactly. And you have also animation, easy to do.
That's right. And then we'll spend a little bit of time on WebGL. I think that's one of the exciting, more geekier technologies that we have in IE 11. The ability to write 3D directly in your browser is something that's going to open up brand new opportunities for developers. And there are many other features that are also in Internet Explorer 11 that we're not going to have time to talk about today. And one of the things we will also discuss is how this works inside of the apps. We talk about it in the browser right now, but all these features are also available inside of a Windows 8 app when you're writing with HTML and JavaScript as well. So get started. I'm going to open up Internet Explorer Test Drive on my computer here. So what we have here is a demo with the House of Cards trailer that we have from Netflix. And one of the interesting things about this is that it's a plugin-free environment. If we were using Flash or Silverlight or something like that, when we open up our menu, we would have information about that technology here. But in this instance, to play this video, you don't need any plugin, and it might take a few moments to load here. Oops. Something went wrong. Try it one more time. If it doesn't work, you'll just have to take our word for it. Well, that's what happens when you do a demo live. You never know what it's going to hit. But if it were working, it would give you the ability to play that video directly in the browser without any plugin. And at the same time, the media is encrypted. So it's protected.
Exactly.
It can't be hijacked when it's coming down to your browser, which is one of the reasons why they would use a plugin in the first place. So it allows them to continue to develop without relying on plugins in the past. And for those of you who haven't seen this site before, the test drive is a really great place to go and test out some of the newest technologies that we have in the browser. Everything from WebGL to Canvas, the encrypted media extensions generally are all going to have a representation here and an ability to kind of try that out. One of the other new things that we have inside of Internet Explorer is the F12 tools. And this is an exciting change for me. I'm actually going to open that browser back up. So when I hit F12, I have a brand new tool set right in the browser for helping me do everything from determining layout and how I want to see layout changed on the page to testing the performance. So in this case, the DOM Explorer, I have the ability to edit the DOM live. So if I want to click on something here and I say, okay, look at this div and see what's inside of it. I text here. I can actually make a live edit to it and say, hello, David, and see that change right there in the DOM. So I'm able to do live edits. If I want to do them drag and drop and change it and see how the layout works, I can do that right inside of the browser without having to open up any other tools. David, what's of these new F12 tools, do you have any favorites of your own?
Obviously, my favorite is around the performance.
Mm-hmm.
There is two performance tools that you can use. There is one for the profiler, which is more related to JavaScript.
Yeah.
And there is another one related to responsiveness and the ability to define where the CPU and the GPU are working in painting, in executing your code on the garbage collector. And I spent a lot of time using that tool to prepare the next demonstrations.
Yeah, I'm sure that it was very handy when you're working with WebGL. So I have that tool open on my desktop here. What I'm going to do is I have the test drive page here open, and I'm not going to do anything special, but I'm going to hit the profiler, move around the screen a little bit, and then stop it. And what it's going to do is it's going to generate a chart for me to see exactly what's going on during that period of time when I was profiling. So here I have a breakdown of the rendering that's happening, the styling when it's applied.
I think there is a small bit of garbage collector, the yellow one.
That's right. The yellow one will be a garbage collection in there.
Exactly.
Anything that's happening during that time period will be represented here, and it gives you a good idea of where the memory is being utilized.
Exactly.
If you're doing too much garbage collection, you're going to see it here, and you're going to be able to go back to your app and make changes and then see exactly how those changes affect this.
And it's really helpful because when you want to achieve maximum performance, you have to be sure that everything is really sharp and be sure that you don't spend too much time on something that you don't want to.
That's right. So plenty of new tools here in F12. The emulation is very handy for quickly changing your document mode or your browser profile, or even if I want to change the user agent and see how the page is going to change for that user agent. I can do that right here. Testing orientation, even simulating a GPS position. So if you're using GPS in your app and you want to see what it would look like if you were reporting from another locale, it's easy to do that right here. So great new tools that we have. So as we talk about using the web inside of Windows, we continue to develop those integration points, points where the user can integrate what they're doing on the web more with the operating system. And pinned sites is a really great advancement in that area. So I'm actually going to go to my desktop here, and on my desktop I have pinned the MSN site. And so I open that up and it opens up MSN. And one of the things that you're going to notice when I go back to the desktop is I'm actually getting live tile updates from that website directly on my start screen. So I can change the size here. I can change it from a small, other sizes.
It looks like a true application, right?
That's right. It gives you the ability to give the user a preview of what they would see if they open up your website. So here MSN is just giving us top headline news through the pinned tile. So this is very easy for us to do as developers. We actually just add a few meta tags to the page here. We can specify the application name, the color of the tile, the different images that we're going to use, and you can decide which sizes you want to support. In this case, MSN supporting all the different sizes. And then it's actually going to use a site that we put out there called Build My Pinned Sites to turn an RSS feed into a live tile. So it's reusing its RSS feed. When it updates its RSS feed, it'll update that live tile as well. So
without the S at the end. Yep.
There we go. So Build My Pinned Sites allows you to do this for your website, makes it really easy. You can follow these steps here, put in your tile color, your title, upload the images, add notifications, so pass your RSS feed.
RSS, right.
And then it will give you that code to put at the top of your home page. Then when users pin your site, they'll see those features. They'll see the different tile sizes. They'll see the live updates. So another way for them to experience your web app directly in Windows. Now let's get into one of the fun topics, WebGL. Now we're going to be talking about WebGL in the browser.
Exactly.
So this gives you the ability to do 3D development in the browser. David, why don't you take it from here? Tell us a little bit about WebGL and why it's important to us.
Yep. So WebGL mainly can be seen by two ways. The first one is to use directly WebGL. And for you, I have a small demonstration about that right here. So let's go to the computer. Right. The idea is here is just to use pure WebGL. I mean, I just have right here a small page, and the HTML is mainly just a canvas called render canvas and a call to my own JavaScript code. The thing is, I just need to use a small external library to get rid of the mathematics because I don't want to burden everyone with the matrix and multiplication and things like that. So I have right here a small tool for that. And then something really interesting about WebGL is that you have to learn two languages. You have to learn JavaScript and WebGL to use it, but you also have to learn a new language because you will program the GPU. You will talk with the GPU, and you will use its raw power to display your pixels. And to do that, you will need a new language called GLSL, Graphic Language Shader Language. Graphic Library Shader Language, sorry. Right here, I have two shaders. The aim of this session is not to learn WebGL, so I will go quickly through that. But here I have two shaders. The pixel shader or fragment shader right here, which is responsible to define the color of every pixel in the screen, right? And then what we call the vertex shader. The vertex shader is responsible for the geometry part. I mean, I send 3D object to the GPU, and the GPU have to produce 2D object, right? So there is some kind of mathematics like in this kind of things. So here are the two shaders, and then I will show you the JavaScript code. So the first thing I have to do is just to get my canvas, define the internal size. Right here, I just say that it's full screen canvas. I have to get my WebGL object. And this is really interesting because I spent a lot of time when I was young asking myself why there is a get context on the canvas, because I always get the 2D version of the canvas. This is exactly for that, because you can now get a new context, which is 3D. So I use here experimental WebGL because it's like vendor prefix, it's not finished.
Correct.
So right now we just have to add the experimental WebGL, and I get my WebGL context.
So when we're working with the canvas, and we have a hardware accelerated canvas in Internet Explorer, we write on the 2D layer of it. And that's something that we're pretty used to doing. We can put images, we can draw shapes directly on there, video, pull frames from a video and dump it right onto a canvas. But and as you mentioned, we would always write to the 2D context of that. And I remember for years I've told people, well, they've asked about the 2D context and whether there was a 3D, and I would tell them not yet. Right now we're just using the 2D context. WebGL introduces that. They introduce a new context to that same element. So the canvas is the same element we've always used for
just drawing. A rectangular area where you can control the pixel in 2D or in 3D. This is a good thing.
Now we use WebGL instead.
Exactly. I also have right here a small function that just have to get to the DOM to get back the shaders code and compile it. There is a lot of things right here. I have to compile because we are creating a language for the GPU. So it's like creating a C++ application. You have to compile, to link, and to execute your code. This is right here the same thing. You just have to get your shaders, compile them, attach them, and link them. It's like a true compilation. Once your code is ready, you can use it, and then you can communicate between the CPU and the GPU through variable. The name of the variable right here is uniform. We call that uniform. And uniform is a variable that you can set on the CPU and that the GPU will use. Right? So here, a part of the code, I set some matrices right here. I define the geometry of my object, meaning, okay, it's just a triangle right here. I just define the position and then the color. And finally, at the end, I have what we can call the render loop, which is executed 60 times per second And this render loop just clear the screen, set some matrices, bind my object to the GPU, and finally draw the triangle. It's a lot of code right here, yes?
A lot of code for a triangle.
Yeah, and at the end of the day, we just have a small little triangle running right here. So I would like to show you something more, let's say, appealing, more geek.
Right.
This is the fundamental part of WebGL. This is how WebGL works. Everything is built on that. When you are able to draw a triangle, you are able to draw a city, because the city will just be constructed with a lot of triangle, right? So let's go to another demonstration. This one right here. And this time, I will use another framework I wrote with a friend of mine, which is Babylon.js. Babylon.js is a tool that will allow you to do the same thing, but in a way simpler, simpler way.
Right.
And only with JavaScript, no mathematics, no shaders, nothing like that. Just I will show you a live demonstration of that right after.
Yeah, so this is real important because as a JavaScript developer, it's tough for me to look at WebGL code.
Yeah.
It just doesn't seem natural. So there's just new concepts in there. So Babylon.js, and it's babylonjs.com is where they can find it, right? If it makes it more palatable for a JavaScript developer. It allows us to write in a language that we're comfortable with and use that same power of WebGL, but with less time.
Perhaps the idea is to show you a demonstration. Let me just launch another Visual Studio, and let's go. I will try to live code. So
oh boy, okay.
Pardon me right now if there is some bugs. I will just create, let's say, a container for my website, because I need a website. Let's use C#. We won't use C#, but I just need somewhere a container. Right. I go there, and I just need to link Babylon.js, the JavaScript file, right? Just put right here. Nothing more. And I will then add an HTML page, let's say index.html. All right, with the right extension, HTML. Yes. Okay. And then I will just link my JavaScript. Okay. Mm-hmm. As we just said, we need a canvas. So let's add a canvas. Let's call it canvas. Watch. And a small script will be required. So no shaders, nothing like that. Mm-hmm. Just a script. The first thing I have to do when I use Babylon.js is to create an engine. The engine, yes, is responsible. I have something wrong with the index. Yes, it's better. The engine is responsible for you to the communication with the GPU. It's responsible for the shaders, for the mathematics. So you just have to call and create an engine, say that the engine will work on the canvas, and you're done. All the WebGL stuff is right there. So right now we just have to play with some cool objects. So we have to create a scene. A scene is responsible for handling all the objects that will be displayed on your scene. So let's create a scene. The scene will use the engine to work. The first thing that I want to do when I am a developer is to define where I am in the scene. So for that, we have a camera. So let's create a camera. There is many kinds of camera in Babylon. One of them is the arc rotate camera. It's a camera which is positioned on a sphere around a point. So you can go and rotate around a point with your camera. Mm-hmm. Okay? The camera is just looking in an object.
So that's the angle that the user would see it from.
Exactly. So the camera will be called camera. Watch out. There is two angles for defining the position of the object. So the first one will be, let's say, O, and the second one will be, it's magic number, right? Mm-hmm. This is the radius of the sphere. And finally, I will just define the center of the sphere. And I will be center on the 0. Finally, just add the scene. Okay, this is a camera. The camera can handle for you everything that is related to input, meaning the touch, the mouse, and what you want to do for interacting with the camera. So just call attach control on the canvas. Then we will need light. Let's add a light. There is different kind of light also, but right here I will use a point light, which is like, you can imagine a sun. It's a point, and it shines on every direction. The point light will be called, let's say, omnidirectional, and it will have a position, vector 3, once again, we are in 3D, don't forget that. So X, Y, and Z, far away. And it's attached to the scene. All right? Then finally, a little sphere. There is two ways to create object. You have, let's say, standard basic shapes, sphere, box, cylinder, and we also support 3ds Max, Maya, and Blender if you want to create more complex object, if you have 3D artists with you. So here, I will just use a small version, a sphere, right? And the sphere will have a name. And here, I will define the precision of the sphere, because don't forget that we will use triangle, only triangle. So I can add a lot of triangle, and in this case, the sphere will be smooth, or just 2 or 3, and it will look like a box. Okay, so let's say that we had like 16, it could be good. The radius of the sphere, the diameter of the sphere, and the scene where I want to add my sphere. Then we will create, the last thing that we need is the material. The material will define how the sphere will look like. Okay? So let's create a single and small material. It will be a Babylon.standard material. Always a name, mat, and always the scene. All right? And then the material will be really simple. I will just say that the material dot diffuse color, which is the basic color, will be, let's say, choose a simple color, red. So it's RGB. And I think it's okay. So I just connect the material to the sphere. And the definition and the description of my wonderful scene is finished. The last thing I have to ask to Babylon is render the scene as fast as you can, because the faster you are, the smoother the image will be. So here, I just ask the scene to run the render loop for me. It will be just an anonymous function. And here, I just ask a little thing, which is scene.render. Okay, so I'm praying the God of the demo makers and just launch the thing. And it works.
There we go.
Okay, I will just have to add a small CSS because everything looks so small right here. Let's say that the body, the HTML and my render canvas, sorry about that, will have a width. I'm not used to the query. Width of 100 and 8 of also 100. Okay, try again. Okay, and this is my wonderful 3D object. I can zoom with my mouse. And the thing is that I can also use the touch. I just have to remove one thing is here. I don't want IE to handle the touch for me, just removing by a small CSS. And then I can also use the touch. I can pinch to zoom. Everything is handled for you. So
that's done with the framework.
Yep, the framework here. So as you may see, there is no shaders, no mathematics,
That's right.
just some, let's say, vector 3, which is a small position. And at the end, what we can get with that kind of framework is this one. Okay, so for this demonstration, the code is pretty the same. There's just a big difference. I asked a friend of mine to create some really cool 3D assets.
Yes.
He used Blender to do that. So just having a look at the scene and the code here. The code just check the support of WebGL, because if you are running on an old version of the browser will not support that. Just creating my engine. And I use a tool called babylon.sceneloader, which will take care for you of loading all the assets and creating everything that the camera, the light, and the object. So all the code is here. I load the scene, I attach the control to handle for me the inputs, and I run my scene. Let's go. Yes, please. The small warning in the bottom of the screen was an ask from AI asking me to allow it to save all the scene into an indexed.db base, just in case I will not be able to connect to the network. We have a complete offline scenario available through indexed.db. So here is my scene, and just with my mouse, I can wander around and I can move. I have a complete collision system available. So, for instance, I can go upstairs.
So you're not walking through walls? Or
I'm not
like
walking through walls. This is like the true life, meaning I can go here and I can have a look. I can move with touch directly. And everything is plugin free inside your browser. Just
So you have a whole 3D world here, and you have basically images that are used to provide the
textures.
The textures?
Exactly. I can show you here are all the assets, let's say, and just open them here. You can see the texture for the trees, right? It is only images, small images, and obviously some Babylon-related data to save the geometries and the definition of the scene.
Yeah. So all of that in the browser.
Exactly.
A 3D world without any plugins.
Any plugin.
And it's performing pretty well, too.
Exactly. The last thing I want to show you is that you can also play with Babylon, even if you are not a developer. You don't have to think about creating a web server and deploying things on Azure or whatever you want. We just have what we call a sandbox on babylonjs.com/sandbox. And you can here just play with a drag and drop tool. You can create your scene, export it on your computer. It will generate all the texture and all the geometries data. And you just have to Control-A, select everything, and by the magic of HTML5 drag and drop on IE11, I will just check, release, drag and drop, waiting for the scene to load. And ta-da! I just can play with my scene without anything, without no code, just drag and drop.
Yeah. That is pretty amazing.
Yep. So this is for the, let's say, IE part.
Yeah. So we're going to talk a little bit now about HTML5 apps,
Exactly.
Windows Store apps built with HTML5 and JavaScript. So we've been talking about all of these new technologies. Well, these same technologies that we've introduced for the browser, for the web apps, we've also built into the HTML5 Windows Store environment as well. So we talked a little bit in the first session about what an HTML5 app is, how it's made. It's, in essence, the same files, the same code that you would write on the web is packaged and stored as a Windows app. The user then goes to the Windows Store and downloads it and uses it just as they would any other app. Written in HTML5, CSS, and JavaScript. If you're utilizing languages, or frameworks on the web, bring those same frameworks.
Exactly. And it works.
into the HTML5 environment here, and it'll just work. So if you're using jQuery or using YUI or Dojo, AngularJS to write your apps already, you can continue to use those libraries to jumpstart your app development for a Windows Store app as well. Now, in addition to that, we have WinJS, which we'll talk about in a few minutes, which is a library that Microsoft provides to help you build those Windows Store elements. So that'll be things, everything from app bars and nav bars to building out, a data binding to your hub page. So any of those controls that you might have on the XAML side, WinJS brings that into the app for JavaScript developers as well. So the app environment uses Trident to do its rendering, just like Internet Explorer 11. It has the same security features that you would expect. One of the big differences is you have access to the WinRT object. So there are going to be things that you can do inside of a Windows Store app that you can't do inside of the browser. And I'll show you a demo of that in just a moment. From the Microsoft perspective, again, here's a lot of the apps that we use, that we've written using HTML5 and JavaScript. So as Pete mentioned in the last session, we kind of dog food this ourselves. We know that it's a great environment to work with because we use it a lot to work. When you look at things like the Bing apps, and if I bring open one of those here and look at the news apps, you'll see a really fluid environments. You'll see a lot of different types of elements. When I get into an article, you'll see layout with images and text together. CSS is the perfect environment for developing this type of app because when we don't know which images, what text we're going to be using, every article is a little bit different. CSS allows you to build those type of template pages that can get these nice fluid layouts where the text rolls from column to column. Talking a little bit about the structure of an app. So in essence, we start with our app. So this is our HTML5 and JavaScript code at the very top. And then we have access to WinJS as a library, or as we mentioned before, any other library, even Babylon.js.
Even Babylon.js,
can be used inside of an HTML5 app.
I have a demonstration for that.
We then have access to the WinRT object. So any of those store APIs that we want to use inside of our app, we can do that with JavaScript and HTML. It then uses the IE rendering engine and, of course, runs on top of the Windows system as well. So every app is managed by the operating system as far as memory and things of that sort as well. So it can be open, closed, suspended by the operating system to make more space for your app as far as memory-wise, or suspending it to make more memory for other apps and manage that as well. Okay. Now, some of the differences from the web environment that you need to be aware of. When we give you access to the Windows runtime, there's a lot of things that you can do inside of Windows, everything from connecting to USB drives to Bluetooth to cameras that you can't do safely inside of the web. So we have a layer of protection, a security model, to make sure that there isn't any code that's brought down from the web that could do harm to the user through the access of these APIs. So we do have that security model in place that stops you from doing things like inner HTML of content that's brought down from the web. It uses the IE11 doc model, so instead of switching between doc models like a browser would, it will always render as IE11. And then, of course, when you're inside of an app, you have not only access to all those WinRT, but you're also storing it on the user's drive. So it's a local application. So you can do a lot more with offline content because you can have the user download that content from the store and run it. Okay, I'm going to skip ahead here and do a little demo for you. So in the first session, we looked at Yeti Bowl. And it was a fun game that's actually 2D, written on the hardware accelerated canvas, where I can, I'll bring it up here real quick. I'm a Yeti, and I can throw snowballs down the hill to my hikers and knock them off. Now, one of the things that you notice is I added something here on the HTML5 store app version that wasn't on the web version. It's this little power up button. So I'll walk you through that real quick. And what I'm doing is I'm going to do an in-app purchase inside of my app. That's something that I have access to when I'm a store app that I don't have access to on the web. So in essence, I'm loading an in-app purchase. I'm declaring that ahead of time in my in-app purchase consumable XML. And just for the sake of time, I'm going to kind of let you do a little research on those details yourself instead of walking through all of it. But I declare ahead of time what those consumables are. And then when the user clicks on the Buy Me button, I'm then going to, in this case, use the simulator for the store to simulate what would happen if a request is made to the store, where the store would then handle that purchase and then return whether it was successful or not back to the app. So in this case, I want to buy a power-up. And when I hit that button, I have my store emulator come up here, and I can determine what type of error code I want the store to handle. In this case, I'm going to say it's OK, that it was a successful purchase, hit continue. I put a breakpoint here so that we could see what's happening. It's going to give me a result for the fulfillment that is either going to be successful or not successful. In this case, it was successful. So I am running a little bit of JavaScript. If it wasn't successful, I would then come into the else when it was not fulfilled and run different code there. But I'm going to go ahead and continue. And now I have this power up button here. Now let's give it more time. Let's start over here. So I have this power up button, and when I hit that, I now have a huge advantage to my little hikers here with this enormous snowball that I spent $30 for on the store. But these are the type of things that you have, it's worth it, definitely, you have access to when you're a store app that we just don't have access to on the web. Exactly. One simple example of using WinRT inside of the HTML5 app to be able to access some of those cool geeky features of Windows 8.1, like a consumable purchase. David, what about WebGL in this environment? If I want to use WebGL in a store app, is that possible? Are there any limitations that I need to be aware of?
It's possible, and there is no limitation. And I have two demonstrations for you guys about that. The first one is the small WebGL 101 I ran just before. The same code right here. My dependencies here is the matrix, which too much JavaScript code. And right here, as you mentioned, there is a bit of WinJS to take care of everything related to Windows. But right there, I just drag, copy and paste my code right here. The same thing, the same stuff I just talked about just before. And when I run my application, ouch. Yep, I have a bug. What is the problem right here? I have to re-reference WinJS just to be sure, right? Oh yeah, I saw. So here is my application. The same thing, the same code, just an app around it. I have the charms. I can add, as you mentioned, let's say in-app purchase or whatever. This is the same code. And if I want to go further, let's take another application right here. And this one used Babylon.js and used the same scene, the museum. But I added some cool stuff. We'll see. So a beautiful long screen, a loading, and my scene, okay? And I can go in the same way. I have the collision, blah, blah, blah. But right here, I also added some settings in the charms bar. I can change the game options. And let's say I would just want to use the touch. So when I move my finger on the screen, I can go without the keyboard or whatever. I can also use a gamepad, if I have one, and I can also use device orientation. Alors, I am not sure that this computer supports device orientation, but if I move the huge screen right here in this way or in this way, I will...
move you around the scene.
Exactly, I will move.
And you put those settings inside of the settings charm, because if you're using a Windows 8 app, as a user, that's where you would expect it.
Exactly. It's not just about copy and pasting code, it's also about adding a better integration experience. And right here, I have my own code, the Babylon.js code. And for the history right here, for the record, I use C++ code right here to communicate between my Windows 8 application and the gamepad, because the gamepad is accessible through direct input, which is in DirectX. So here I have C++ code, here I have my own code, my JavaScript code will reference the C++ code, and here it's all about JavaScript. Just JavaScript.
Right. So talking Babylon is a framework that we use inside of the apps. Well, there's other frameworks that we want to walk through really quickly as well. So JavaScript frameworks in HTML5 apps. First of all, let's talk about WinJS. And WinJS allows you to have the Windows look and feel of your components, and it makes it very easy for you to build those components out on the page. So when I build an application, I want it to match the OS that it applies to. So in this case, for Windows, I want it to be familiar to a Windows user. I want to use app bars, nav bars. In Windows 8.1, I have things like nested nav bars now accessible to me. Integration to the charms and search contract, those type of things. So WinJS is a collection of files, it's JavaScript files and style sheets, allows you to build those out, gives you even things like data binding.
And it's pure JavaScript.
It's pure JavaScript. It's a library that you add in just like you would jQuery or Dojo. In WinJS 2.0, we have some new features. We have improved controls. So list view has gotten significantly better in performance. The new app bar, new controls that we have, hub, navigation bar, search box is something new where a lot of apps now put the search right on the screen, and that's something that WinJS provides for you, as well as new infrastructure and building blocks as well. So many new things in WinJS 2.0. But we don't want to forget about the frameworks of the web. So we have the jQueries out there. We have the JavaScript libraries that we've been using for years. Those same libraries work inside of the Windows Store apps. And it's not jQuery or WinJS. Those libraries can work together.
Exactly.
Just like the web, utilizing multiple libraries to bring in different features, the same thing works inside of this environment.
This is the same story.
It's just HTML and JavaScript. So whatever it is that you're used to working with, bring that with you whenever you write apps for Windows. So just to summarize, web apps have more integration in IE 11. So we have not only new features, but also things like charm integrations and the live tiles and being able to do different size tiles as well. Windows 8 allows you to reuse your skills that you already have, as well as the libraries or the code that you've already invested in. And JavaScript can make your store apps development quicker.
Yep.
You can reuse code that you've written. You're using a language that you're already familiar with. So instead of learning a new language, bring that language with you to write your Windows Store apps. So we got a lot more today about writing HTML5 apps and store apps and a lot of the different cool features that we have that you can do with it. But for this session, that's all that we have for you. So thanks for joining us.
Thank you, guys. Bye.